Go.
Hello, my dear students, and welcome to our second video help session for Chapter 3.2. This particular assignment develops an important skill, and that is not determining formula mass, but calculating formula mass. Given a formula, give me the formula mass, because we're going to need that molar mass when we work problems all through the rest of the course. So let's get right down to it. The first one asks for number 1, ammonium chloride. Uh-oh. Do you know your polyatomic elements? Probably not, but if you had a table of them straight from your book, you would know that ammonium is NH4+, and chloride is chlorine Cl-. And they come together in a 1-to-1 ratio. This is the ammonium ion. It is a I need to magnetize something over there. It is a polyatomic ion with a +1 charge, and these stay together as a group. But it says, what is the formula and formula mass? Well, there's two ways to do this. The right way that you need to be able to do during testing. And so this has one nitrogen, which has a mass of 14.007, according to my periodic table. I'll comment about that in a minute when I tell you the other way to calculate it. It has hydrogen, and I need 4 times 1.008. And all I'm doing is taking the atomic mass, not in atomic mass units. This is best, if you look on your periodic table, it won't have any units anywhere. It will say average atomic mass or standard atomic mass or standard atomic weight or just atomic weight. And there's no units. Well, we make up those units of atomic mass units. We describe or define them as one atomic mass unit is 1/12 the mass of an atom of carbon-12. Of course, all the carbon in the world is not carbon-12. It's a mixture of carbon-13 and carbon-14. 99% is carbon-12. But this is a little higher than 12 because on average, this is a weighted average, carbon weighs 12.011. Well, and now I have a chloride, and I looked it up, and it is 35.45 grams per mole. Grams per mole. Grams per mole, not atomic mass units. And if we add this up, 14.007, 1.008 4 times, and 35.45, you get, or I get, 53.489. Now, what are you going to do when you're working these at home? And there's your answer, okay? When you're working these at home, one thing you can easily do is just Google ammonium chloride. Maybe do formula, and it'll pop up with the formula. The other thing it'll do is it will pop up with the formula weight. And in this case, when I Googled it, I got 53.491. 0.02 of a gram per mole difference. Why? They used different periodic tables, greater masses. Okay? So, I'm going to try something. Don't pan down. Let me just do this and see if I can get the sound of the fan off from the back. And make it a little quieter in here. So, that's your answer for number 1. You can look it up, but be aware of how to calculate this, because you won't be able to look it up on the test. You won't have your phone or Google. The next one is sodium cyanide, NaCN. I'm going to go through this quickly so you don't have to spend much time with it. But, excuse my dog shaking his collar right here. Sodium is 22.99. Carbon is 12.011. And nitrogen is 14.007. If you add that up, sodium cyanide, NaCN. The cyanide anion, Cn minus, and the sodium cation, Na plus, come together to form this ionic compound with a formula weight of, if you add up 22, 12, and 14, you get 49.008 grams per mole. I would be happy with 49. Sodium is 22.99. We just call that 23. Okay? Carbon is 12.011. I just call that 12. Nitrogen is 14.007. 12 and 14 is 26. And 23 is 49. Do you care about this out here? Not for any of our laboratory balances, and not in most routine applications. So, number 3, before I move over, is magnesium hydroxide. Now, if you look this one up, magnesium hydroxide is, I want to say, is a hydrated salt or compound. You might find different molar masses, but if you take 2 times 16 for oxygen, 2 oxygens, or you can use the 15.999 from the periodic table if you like taking your time, 2 hydrogens at 1, if you want you can do 1.008, and 1 magnesium at 24.305 grams per mole. Magnesium is +2. The hydroxide OH minus is -1, so we need 2 of them. So if I add up 2 oxygens at 16, 2 hydrogens at 1, and 1 magnesium at 24, I get 58.319 grams. For number 4, it's calcium phosphate. 3 calciums at +2 each, and 2 phosphates. So, parenthetically, 2 phosphates, PO4, 3 minus. That means I'm going to have 8 oxygen atoms, 8 times 16, 2 phosphorus atoms at 31 apiece, 30.971, and 3 calciums at 40 apiece, 40.078. And if you add those up very carefully, and don't look it up on the internet, depending on what periodic table you use, you'll get 310.168 grams per mole. Okay? When I look for an answer, I'm not going to be quibbling out to 5 places, because different periodic tables use different values. I don't know why we can't just look at the IUPAC website, which is the International Union of Pure and Applied Chemistry, who sets the standards. Anyway, let's continue on. There's, this was not 1, 2, 3, 4, but this was A, B, C, D. We have E and F, lithium carbonate. That's going to be a small one. Lithium is a group 1 metal. It is the element number 3 right here, and it's only has 3 protons, 3 electrons, and about 3 neutrons on average. It has a very small, 4 neutrons on average. It has a very small molar mass of, atomic mass of 6.94, and I need 2 of them. And carbonate, CO3, 2 minus. So this is always +1, this is always -2. So there's my lithium carbonate, that's the formula. And if I add up 3 oxygens at 16 and 2 carbons at not 2 carbons, sorry, 1 carbon, 1 times, that's a 1, times 12, and 2 lithiums, which, if you look on the chart, it's 6.94, 2 times 7. This is what you'll get, right? 3 times 16 is 48, and 12 and 14. 2 and 8 is 10, and 4. 2 and 8 is 10, and 4 is 14. Carry my 1. 1 and 4 is 5, and 1 is 6, and 1 is 7. You'll get 74. When I used the values from the periodic table and added them all up, I got 73.89 or 888 grams per mole when I did it very carefully. When I did it in my head just now for you, I got 74. I'll take either answer. Now be careful. Not every element is close to a whole number. Carbon's 12, nitrogen's 14, oxygen's 16, hydrogen's 1. Sodium is 23, but some of the others are not so obvious. For example, chlorine is 35.4. So you can't always do this, but for practical purposes, if I were going to go weigh out some lithium carbonate in the lab, I would just do that. Unless I was weighing out tiny amounts or pharmacological amounts or needed to be very accurate. And sometimes you do, then you would use that. Okay, so F is hydrogen sulfite. Its sulfate is, SO3. Is that right? Or is it SO2? Well, I'm saying it's H2SO2. H2SO4. It's SO3. It's SO3. There we go. So, and this is always 2 minus, this is always plus 1, so I need 2 times 1.008, and I need, for hydrogen, for oxygen, I need 3 times 15.999, and for sulfur, I need 1 times 32.06. And if you add that up, you will get 82.073 grams per mole. That's your answer. Hydrogen sulfite, which would actually be sulfurous acid. Now, I have some paper left, so let me be conservative with my paper. The next one is this compound SbBr3. Sb is antimony. It's an unusual metalloid compound, or not metalloid compound, metalloid element, and we have 3 bromines. Antimony is a group 5 element, and antimony is 121.76 grams per mole. It's atomic mass. And bromine, and I need to stop and talk about bromine since we're in Arkansas. Sorry, but I use these help sessions to supplement the fact that we're not spending that much time in class. Now remember, if you take a 3-hour class, that assumes 3 credit hours, which means 3 hours a week. The higher education, commission, or if you're Southern Schools or whatever commission, the Higher Learning Commission, the HLC, has determined that means they define an hour as 50 minutes. They give you 10 minutes for passing classes or moving between buildings or for breaks or whatever. But that is 3 50-minute classes or 2 hour and 15 minute, 75 minute, 60 plus 15, 75 minute classes for a total of 150 minutes a week. And looking over these video lectures and doing these video help sessions don't quite compromise that. And here's the other thing. When I teach this chemistry on campus, these video help sessions are my problem solving help sessions that are held, usually I hold them in the afternoon, separate from class. Okay? But I do want to talk about bromine. I need 3 of those. And if I add this all up, I get 239.712 for my bromine. This is grams per mole. And the antimony, there's only one, 121.76. So if you add that up together, the formula weight of this compound is 361.472. It asks what percent of this is bromine. It has the bromine in bold, okay? Bromine in bold. And that means they want to know the percent composition of this. If I hand you a sample of antimony bromide and I say how much bromine is in there, the way you would do it, we would say, well, bromine constitutes 239 grams, 0.712 grams per mole, and grams per mole if you want, per mole of this compound. And 1 mole of this compound is 361.472 grams per mole of this compound. Well, my units cancel out because this is going to be a unitless value. I want the fraction of this, and if I do the math, this comes out to be 0.6632 and a bunch of calculator vomit beyond. We're not going to use more than 4 significant figures, just because it's not really necessary. And if I multiply this mole fraction by 100%, I get 66.32% bromine. Okay, so here's how you do it. You calculate your formula mass, and whichever one it asks you for the percent composition, you divide its contribution by the total to get and multiply by 100% to get to that value. Have you ever been to Smackover, little town north of El Dorado, as the rest of the world says, but El Dorado, as they say in Arkansas? And have you heard of the El Dorado Promise? If you went to high school in El Dorado, they promise that they will pay your college, 4 years of college, 100%. Not depending on what you made on your SAT, not depending on how good your scholarship essay was, but for graduating from high school, 100%. Any college, and they'll pay up to if you go someplace expensive like Wichita Baptist or Lyons College, both very good schools, but private schools, they'll pay up to the maximum public school amount for you to go there. How? Well, some of the oil companies, one in particular, made a lot of money at an oil rush in the early part of the 20th century here in Arkansas. Everywhere they stuck a pipe, oil came out of the ground. They stored it in they didn't have the infrastructure they have now. They didn't have pipelines or railroads and railroad cars. They just made giant ponds of oil, lakes of oil everywhere, and then pumped it out as they could use it, sell it, and refine it. But they made a lot of money. And that oil, as you know from Shell and its, depiction of dinosaurs, not Shell, but not Shamrock, but Dinoco in the movie. But there was one. I'm trying to remember, had a dinosaur. Shell has a shell for their symbol. It's because oil forms from ancient organisms that settled to the bottom of the sea. Silted land covered them over, under tremendous pressure and weight, they were converted to oil. And you can drill down in there and you can find the remnants of their shells and things like that, microscopic broken fractured cells and the like. But here's the other thing. Trapped on the water underneath El Dorado and Smackover are vast stores of ancient seawater that are highly enriched in bromine, this element bromine. And bromine is very unique. It's one of two elements in its elemental form that's a liquid. The other one's mercury. And it's naturally found in seawater, but this seawater is concentrated. And they have Br minus in there. And they do a single substitution reaction to replace the sodium bromide and to reduce the bromine to Br2 to its elemental form. Actually, that would be an oxidation, but they have to convert it to its elemental form, and it's a nice chemically safe reaction. They add chlorine, they get chloride back, they get liquid bromine, they put it in tank cars, and it scares the hell out of me, and ship it up north, because I see these trains with 100 tank cars full of liquid bromine passing through my town and other towns here in the Delta headed north to take bromine, which is a major component of plastics, or it's used in forming plastics, medicines. In fact, a name your grandparents or great-grandparents may have used for a medicine that settles their stomachs might be a bromide. I need to take a bromide to feel better. That is named after the bromine in there. And Arkansas, at least at one time, was the world's leading producer of bromine. I mean, more than Saudi Arabia, more than Canada. Now I think our state is number 3 in the world if we were a country. So a significant proportion of the world's supply of bromine comes from there. And the reason, if you've ever been to Smackover, you drive through the town, it's like all these mansions, but where's the businesses? Where's the money coming from? It's coming from underground and from chemistry, from the chemical industry and the oil and gas industry. The oil and gas, the oil's gone for the most part, but the bromine remains, and it's a valuable feedstock chemical. And Arkansas is one of the world's leading producers. So there's your homegrown chemistry lesson. Now, we have 3 more quick problems, and I'm going to work them that quick. The next one is arsenic iodide, As2I4. So, that's its composition, and yet if you were to look for its empirical formula, it would be what? ASI2. Anyway, this is B. And they want to know what percent of that is arsenic. Arsenic's toxic. That might be something I'd want to know if I'm working with this compound. How much arsenic is really in there? I need to calculate the lethal dose I'm being exposed to. So, arsenic is 74.922 times 2, and that's 149.844. 74.922 grams per mole. And iodine is 126.90, and I need 4 of those, and that would be 507.6. And if you add these two together, you get a formula mass of 657.444. Now, if you want to look up arsenic iodide on Google, or in Google, or with Google, I'm not sure what preposition to use there, then you can do that. You might get something a little different, but I promise you your values won't differ. But you still need to calculate, you still need to know the formula, and you still need to know the atomic mass of arsenic, which, again, is a group 5, it's right above antimony. It's a group 5 metalloid that has a mass of 74.922. But there's 2 of them. So I divide 149 my contribution from arsenic by the total, 657. If you want to punch in 0.444 and 0.8445. And when you do that, you will see it's 22.8% or 79% arsenic. Okay? C is aluminum phosphate. Maybe I want to do an elemental analysis and determine how much phosphorus is in this that I'm going to add to my plants. Because I want to add a phosphate-rich fertilizer. This wouldn't be a very good fertilizer, but how much phosphate is in there? Well, aluminum is a metal, always +3. Phosphate is a polyatomic anion. The tends to stay together, and it's always -3. But aluminum is 26.982. We'll call that 27. Phosphorus is 31, but we're going to be more accurate, 30.974. And oxygen is 15.999. Which I call 16, and I think most people do. And the problem is there's 4 of those, okay? But it's not asking us, so all I need to do is multiply that by 4, add these two up, and I see that aluminum phosphate is 121.952 grams per mole. Okay, I'm going to call that 122. So if I want to do my percent phosphate, it would be what? 31 divided by 122 times 100. Its mole fraction would be 0.254, but that's equal to 25.4% phosphate. Okay, not phosphate, phosphorus. Phosphate is this whole species. Phosphorus is the element. So I misspoke when I called phosphorus phosphate. Ooh. And that's a big difference. Okay, this next one is some compound. I actually don't know what it is. C6H10O. Probably some ketone or aldehyde. Hexaldehyde. Anyway, 6 carbons. But this would be, carbon is 6 times 12. You can say 12.011. Hydrogen is 10 times 1, 1.008. And oxygen is equal to 1 times 16, 15.999. Because there's 6 carbons, 10 hydrogens, and 1 oxygen. Excuse the noise in the background, it's my dog. Anyway, if you add this up, you have a compound molecular weight of 98.145. Or you can Google it, but you would still need to make this calculation because they want to know how many carbons are there. So 12 times 6 is 72. It's actually 72.06. And my compound is 98.145. So this compound is about 73.4% carbon. And that is it for this exercise. Watch if I don't get this posted today, because it takes a long time to post these. I'll get these posted tomorrow. And if I don't get it posted tomorrow, some of you have noticed I actually post them to my YouTube channel. And then sometimes provide the link or sweep them over into Blackboard. And you can get to them a little sooner because I put them there first. So, go ahead and like and subscribe on my YouTube channel too. Until then, goodbye now.